Hello, my name is Tuomas. Come from Vianova Systems Finland Oy. And I'm here to telling about the PIM for infrastructure in Finland, lessons learned. So I will go through a little bit what we have done in Finnish market and some sample projects and so on. My background is as a road designer and then been in software business now approximately 15 years. A little bit our company, we are responsible of Finland and Baltics, and we are triple reseller in Tekla Civil and NovoPoint and Thales software. Also reseller to Autodesk and some Oracle and some local softwares. Shortly about what's happening in the infrastructure business today. There is these mega trends, what Sitra has told for 2016. They are doing this every year. But maybe the major three issues is this sustainability crisis now, and also this globalization and independency and technology, which are the major issues what's happening right now in our market. Also, I think it's quite worldwide issue. What I told that we are bringing the latest technology to our customers, how we see these changes in the market and this technology issue is that these data models and BIM has come to infrastructure quite heavily these years. And also with the data models comes this data management. That's quite huge when you compare BIM models in the building side. In infrastructure, the models are 50 to 60 kilometers or 100 kilometers long. Also, the data what is connected to the project is very large. Also, all the time in Finland, for example, they are trying to find more efficient ways to make a design work because we don't have that many designers. Infrastructure design is not that, how to say, sexy business in today. In Finland we have Rovio, these Angry Birds, and then we have this Clash of Clans games. They are taking all the young ones to that business today. Formerly it was mobile phones, but now it's a game business. But basically, to be more efficient is to find a way how you are able to use resources from different places to the one project, like offshoring a lot. Today, the consulting companies, for example, Far East or Asia, they buy design services from there. Also, this IT technology is going very fast all the time. And there is a lots of new softwares, lots of new technologies, also in internet and connections to the servers and that kind of thing. So the cloud services are more popular all the time. Also, these new type of service models, because nowadays people don't want to buy licenses, though, so they want to use the licenses only 1 month or just for the one project. They need lots of help to take in use this new technology, for example, the BIM consultancy and that kind of thing. So that's a great opportunity to companies to develop their business all the time. Also, this forms of contracts and lifecycle management. So the data flow from the design to the construction to the maintenance, it's coming more and more important in the projects. Also now the projects are like customers. There are big projects where you have lots of consulting companies or contractors, these design build projects or PPP, public-private partnerships. So they want to buy the environment to design in the project and use it like a alliance model, for example. And then they don't own the licenses, it's only for time for the project. And we have these new kind of users. So basically these old user interfaces like CAD drawings and things like that, the new users, the young ones who are coming to this branch, they don't like those. They have noticed that there is a lots of in game industry. You have a lots of good user interface. There is a huge amount of people is connected to the one game, for example, and they are asking why it's not possible also in design business. That's a good question, of course. And for example, my kids, which are 16 and 18, if I show our software to them, they are a little bit laughing about that because they said it should be mobile. It should be like this Minecraft game that you have 1 million players in the same time and you can create own worlds and that kind of thing. So it has to be fast. The computer should do lots of things automatically and so on. So it changed a lot about the business, and also the BIM is a one solution for that. We have in Trimble, as a reseller in Trimble, we are part of this Trimble ecosystem. So as you see, there's a lots of different phases when you make infrastructure today. And the data management, like there's a Trimble quadri in the middle over there. So that's the how to handle the data. So the data model and how to use the data model and share and put data to the data model, it's important because all the phases over here, they have a different way to handle the data and find the added value to the project. So as you see here, we are here in this area quite strong. Our responsibility is this design and estimating and biddings. And then we deliver the data to the machine control systems and construction side. Then we go back and collect that data to the maintenance and get that to the back to archives or maintenance systems. So basically the data flow should be seamless through the process. And in Trimble ecosystem, we are able to deliver the software, but also we are able to, with our partners, Scitech and Geotrim, we are able to deliver all the equipments what is needed to make the thing happen. In Finnish market, we started several years ago the work how to get this data flow more efficient, and it shouldn't be based on some programs. It should be that it's open standards, and you are able to use the data in models and also get as rich information from the design phase to design phase and not lose data between those. So in year 2015, we got common infra BIM requirements. So it's a documented way to make a data models in infrastructure design. That was a huge work to do. And as you see, there is everything start with this infra model data exchange. It's a format. It's a land XML based format, which has been done richer for Finnish market. We call it infra model 3 land XML, and you get the data from the software to the construction site with infra model format, and you are able to read all the necessary information and metadata through the format. But then we got the problem. We had the format, so people didn't know how to model things, how to name the models, what are the subsurface names, how is it the top surface or lower surface, and that discussion started. So we made this classification system for modeling purposes. And in the same time, we started this infra BIM requirements. Basically, this is what does these requirements include? And you are able, it's also English version, so we know that other countries are copying quite a lot this because it's good work what we have done. And also what we have copied some from Norway. They have this handbook 138. So still with pride, use it what someone has done already. Maybe the most important thing, it's under the Building Smart. Building Smart Finland is responsible to keep those requirements up to date. There's all the time something new is coming to the data exchange. Also, we fix the classification system and the requirements, and there is a group of people and specialists who are going through all the time the need of market and try to respond to these issues as soon as possible. And then we are sharing this information to all the people in the market. There has been also this 35 pilot projects, over 35. It's sorry, it's in Finnish, but it's a road, railroads, bridges, streets, different type of connections with all of those. And then we have maritime or waterways projects where we have tested these requirements. And all the pilot projects making a report back, what was good, what was bad, what we should develop further. But if you visit this infrabim.fi/eng, so you get the English version and you are able to read the documents. Unfortunately, pilot projects are, I think the reports are in Finnish only, but maybe the most important thing are these three issues, which are the important thing there. That was a big job to do, but nothing happened. So we had the requirements, we had a format, we had a classification system, but then suddenly Finnish transport agency and big owners, big cities, six largest cities, demand for modeling. So they said that you have to deliver after 1st of April 2014. Finnish Transport Agency sent a letter all the people who are working in this branch, and you have to use the Inframodel 3 format. So that was a demand, and after that it exploded to the market that okay, we have to really do and use the requirements and go forward with that. This Inframodel format, it's for road, railway, waterway structures, these earthworks, and we use IFC to the structures like bridges, noise barriers, and these kind of things. So it's a combination of LandXML and IFC. And if there is something what you cannot model with IFC or Inframodel 3, you choose, for example, 3D DVG. So everything is covered in that way. And it's always based on requirements and standard formats. So then it helps the designers and construction sites to develop their processes through that. But that was the big issue that people started to use. And actually now we have projects where people don't use or they don't have demands, like design-build projects, where the contractor is owner of the project. But basically they use the modeling anyway because they have seen now the value is huge when you are making, based on BIM rules, this work. And also, there was 1st of May, came this initial data and present state model has to deliver based on this common InfraBIM requirements. So all has to be documented when you deliver to the next phase. That was a key issue there. From where to feature, quite many in Finland. There are cities and municipalities, small ones, who are saying that, okay, this is past and this is today, and they are almost here. So the scale right now in the market is quite large. But basically more and more people are coming now to this phase that they take BIM in use because the value is there. But we are going very fast now to level 3. I think that's the good news for as a software vendor, but also to the people who want to develop their business forward. And BIM in project life cycles. So if we see where you can start to use the BIM. So actually we use it in conceptual planning already. We can make very good sketches. In Finland we have an opportunity to use material from governmental material for terrain models, very early phase already. It's almost free. And area and city planning, public collaboration, if you have lots of alternatives like this project, and all the feasibility studies can be used in 3D already. Why you should use it there is because when you go to the next phase, you get the model what has been used in the early phase. Then you are able to continue with the same model. And when you have documented where the initial model and the base data and raw data has come and which date, then you are able to trust the material what you have in your hands. And then you go to planning phase, and there is lots of visualization and presentation models, because that's the way how you make a decisions, the financial decisions and also the governmental decisions. And in Finland we have a law that you have to ask everything from the public. So it's very easy way to show the project in proper way that everybody understands that it's a good or bad plan. And also that you are able to make a very accuracy cost estimations based on model, because if you model everything, then you don't forget anything. Then it's more better than just saying that it's 15,000 euros per meter. Now we get more accurate cost estimations. When we go to detailed design, of course, we get also the data from there. And there was a calculation in past years that every time when you go from the phase to phase, it's about 30% of the cost next phase will be used to trying to find out what they have done last phase. So basically, now we save quite a lot money in changing to the more detailed design. But when you have a model, then you have a possibility to make a simulation and analysis. More accuracy comes from there, and clash detection, of course, which is also when you are in city areas, for example, where you have lots of things underground, things like pipes, manholes, cables, and that kind of thing. Of course, from design, we make it the model to build constructible models. And there you are able to use the model more efficient way when you are able to make 4D or 5D models with the time and cost quality, and get the stakeout data straight to the machinery data. But also when you make an offer to build the project, you get the models, so you can check all the things what's there, and if something is missing, you know already when you are starting to build that you have to replan something. And many times, if you are in build area, city area, for example, or place where you have a lots of traffic in rehabilitation projects, this temporary traffic things cost more than exactly the project. So then you can make a plan also top of the model there. So it helps you a lot. When you deliver the project, the quality control points, quality control surfaces, and maintenance plannings and that kind of thing, the model helps a lot. I have one sample about that. And of course, the maintenance, how to use the model in the maintenance. This is what we plan, this is what we get, and you get the real data, what has happened and what is really built and what type of materials and equipments has been used in the project. But the most important thing that you have the collaboration through the process, and it's open. Everybody sees in 3D, everybody gets information as early phase as possible. That's where you get the lots of savings to make it more efficient. I have some samples where you can use BIM infrastructure projects. So, for example, initial model, it's more and more important to get. I will show afternoon one sample about the raw data, how it can be. For example, the pipelines. It's very interesting when you get the maps from for example, cables and sewer lines or manholes. Then you have a lot of, in Finland, is used quite a lot now, point clouds. It's coming more and more mobile point clouds, aerial, ortho, all the possible material. Then comes this traditional survey data, points, lines, surfaces, and city plans, for example. Then you connect the GIS information like orthophotos or soil investigations to the same model. And the key issue is here that when you have a one live model, you are able to share the data. So everybody who is connected to the project gets the real data all the time, and all the updates are in this one place, and everybody can use that. So you don't send lots of emails and text files. And models from the raw data. Normally, of course, terrain model, subsurfaces, pipes, cables, structures, buildings, reference projects. So everything can be connected to each other in these data model servers. And this has been now the key issue, that we get much better, a higher quality design, because this initial model is done more proper way than old times. Old times it was a map, some 3D information, and lots of guessing. Here is city of Tampere. It's a quite large city, a little bit over 200,000 inhabitants. They have in it called city model. It's 3D model. If you go to City of Tampere page and there is open data, you get the 3D model from the whole city. You can download it as a 3D DVG, and you can use it, for example, early phase design right away. They have also lots of information, underground information, all the bridges and things like that has been modeled there. So basically you can start quite good right away. And also here you can see that there's a one early phase sketch. So it looks quite good when you have orthophotos and city model and everything. You merge it there and just make one alignment with the model. So it looks quite good for discussion with politicians, for example. Data management and analysis, you can, of course, take a cross sections, get the 3D model, get the maps, connect the drawings to the model. There is one project where you can see that you are not able to do everything in one. You have to do in different phases, otherwise you break something. And then this is city of Oulu, where made shadow. They was trying to find where the shadow is there. So you shouldn't make a bar under the shadow. Then there is a collaboration model. This is Ring Road 1, Keilaniemi, Espoo. This is headquarters in Microsoft. It was a Nokia past times. So there's a one big project top of the 3 other projects. So there's a new metro line is going under here. There's a station area. Then you get these 4 huge buildings there. And then the whole ring road will be changed. And the place, the traffic is about 35,000 cars per day. And it's in the new road is coming to the same place where it is today. You are not able to close the traffic there. And it will go down approximately 8 meters in the same place. So it's very tricky place. And there was quite many alternatives what they used in early phase design or to find the best solution, and made the decision based on the models already there. Then the same Ring 1, but about 5 kilometers to the east, there was this tunnel with lots of telematics under the department houses, and traffic was high, and they made a 5D model with a 3D model. Time and cost was there, so there was a pilot for trying how to merge these things together. In Oslo, this is center of Oslo. Oslo railway station is in the left side, and in the right side is a new opera house, if you have visited Oslo. And this is the ongoing project right now. So basically it looks always nice when you get the visualization, but all the stuff is underground. So there's lots of things to go. There's lots of cables, and they have modeled even the trees there underground. lots of pipes, cables, and of course when it's center you cannot break anything in the wrong time. Machine control data, it's more and more 3D in machines. So you just get the 3D model there. There's a cross section, there's a longitudinal profile. So actually the guy in the machine has a very good overview what's going to happen, and you can also merge cables and pipes, so they know to be warned if there is something in the underground. This is, you can see here, design model, constructor model, as-built model. This is city of Oulu, small housing area, where they have modeled the cross-section. So normally, if you put it top of there, you can see how it goes. When they didn't have the machine control data, normally they cut it everything away. Now they leave quite a lot volumes over here. And then they can have this in augmented reality to the on-site. And basically over here you can see that there's something wrong with the model and what they have done, so you can make a quality controls also on-site. Maintenance model, maybe the largest project what I have been with. It's Western Metro Line in Espoo, 13 kilometers, double tunnel. I don't remember how many stations, but many. And component model with the GIS information, SIM, civil engineering models, and BIM, IFC structures and MEP. So basically they are saying it's several houses. Between those houses is a train. So, but it's underground and very, very big project today, about 1 billion euros, if I remember right. And targeting maintenance was to get the as-built model, and maintenance planning and operations will be optimized in 5D. Digital service manual in 5D, lifecycle management, and training environment. So basically, the metro line, in that area, it's about 2,000 firemen who has to be trained to this metro line. So normally you build a metro line and then you go and learn and test and train on site. Now we made a game, and with game they can go through the model before it's ready, and they can learn themselves, and then they go only once or twice to the real metro line. So basically you can imagine if they go there 1 week, comparing to 2 days, 2,000 times 3 days, and hours, an hour rate. Even the hour rate is small, you save a huge amount of money of that. And then the service guys will have an iPad or some tablet or toughpad, and they go to service there, and they get all the information from this model to the on-site. Then we have 3D caves, big rooms, and so on. Okay, let's go to the topic, what I promised to tell. So what we have learned about the model, we have done quite a lot survey. Where is the value of BIM approach in the project? I think this was in Norway, what they checked. So always asking, the major issue was in past years, it's this size project, should I use BIM or not? So then they were going to do the budget versus result. So this is a different between the difference between budgeted and result. So you can see it's a 140% over, and in big this is the size of the project. So basically in big projects, of course it's a big money if it's only 5%, but the volume of the small and middle size of project is huge. So basically the result was you should use BIM all the time. So it doesn't matter is it big or small. If you use the BIM, you get the added value from there. There was a master's thesis from Alexander Gerbov. He was making this 2 years ago. And this is about rate the effect that BIM has the following parameters. So if you go time requirement for design changes and additions, So those who has done only no experience in BIM or 1 to 2 projects in BIM says that it takes more delivery time and is it easy to work with and so on. But basically, more you use the BIM, better result you will get. So it's a learning process. It's not that you right away get. You have to learn and use the right techniques to make it. There is what is the value, added value, and communication is maybe the largest issue. So you don't make the iteration with the other designers. So actually you go the whole process and everybody knows that you go the right way all the time. So that saves a lot of time and money in there. Tramline in Tampere, there was this performance issue. Also, it's an alliance project. So actually there is City of Tampere, Via Track, Jaakko Pöyry, UIT, and those companies has merged together in the alliance, and everybody sits, also the owner sits in the same side of table. I don't know if you know the model alliance. And they have a Quadri server over there, and there was a large amount of data, and they used lots of products, different type of products, and also the structural design was involved because there was this service area for tram, and the coordination model was all the time in there, and they used cloud service for data model, and they had a big room with the 80 designers in the same premises all the time, and they were working all together. So it's very efficient way to make a design in there, and there was different companies involved. In Norway, this ring 3, Ulven Norwegian Road Authority calculated average cost for per change if you change the traffic sign place or manholes place and so on. So the average cost is about $9,600. So there was a part 1. The BIM model was not used. About 250 out of 600 changes caused by design conflicts between domains. So they calculated it's about $2.4 million, approximately 4.6% saving extra cost of there. And there is BIM model in the part 2. So those were the same project but divided to 2. And there was almost no design conflicts. So basically, you can calculate there the potential cost savings were the same because the size of the project in that side also wasn't the same. City of Turku, there was a pilot. It was an old train service area, which comes a new housing area. And the street design was very connected to the department houses. So basically there was a house and there was a street, and actually the structure was the same. And also lots of things modeled under the geotechnics because it's old sea bottom and there's lots of clay in that city. So the pilot was focused to test these modeling requirements. And what they did go through is this what they wanted to deliver. So in invitation of tender, they said that, okay, we want the raw data like this, initial model like this, and model description documented, and model in standard formats. So that was asked, and the main issue there was that the client should also audit and check that they will get what they have ordered. So in many projects, people say that they are done it model-based, but they haven't checked. The owner hasn't checked there. And also that the follow-up meetings will be done based on the model. So basically this is a sample. It's classified, all the issues what you model, and who has done it and what has been done and what design discipline. And it's dated and also the raw data and everything is there. So basically, there was a very good result of there that they noticed that the model is done very proper way. And what they got as a model, so the whole area was modeled and the model was delivered to the customer. So there was all this design material, also the native design material, not just the standard formats, but also native. And coordination model, design discipline models. So all these IFC models was also delivered in the, not just this coordination model, but also these design discipline models. And model documentation, and also the viewer package that they could, as a client, they could go through the model with their own time. And of course, official document. So because you are in the city area, the drawings are still there. So it's not just the model-based process there. But that's a big wish now, to get some disciplines to model-based. And I think in bridge design in Finland, some documents can be in 3D. How to continue from here? So owners want BIM-based projects. So basically the requirements are there, and more productivity and innovations. They want the service providers to make more innovations and get more potential out from the modeling. The seamless data flow in the project, open and visual process through the whole life cycle. So it doesn't there is a lots of owners now who wants to see the model in the whole process. When they have a project meetings, they want to see the model, not the drawings, the model. That's the key issue, what we try now to go forward, because it's much faster, for example, place where you have a multidisciplinary project. Higher quality, that's already seen, and that's going to be measured. And use all potential in BIM. Best practices in use and value for money, that's the issue there. Not BIM because it's cool, BIM because it's valuable. That's the main issue there. What we say as a software vendor, you should share the best practices, because your competence is not coming that you have some secret issues. You share the competence or the best practices in that way. Now you make an offer about, because you are very good and efficient designers, not that you are fast digitizing maps, for example. But the main issues I have underlined here: communicate. There is lack of communication all the time. As a Finnish person, I can say we don't speak. If we are drunk, we speak too much. And if we get more drunk, we sing. But that's the designers. Everybody wants to do their own issue there and doesn't want to share the information. That has been a problem many years now. But now the modeling gives a tool for that. Modeling is part of design, not the own phase. This has been a problem all the time when we have done this BIM integration to our market. People make the design in traditional way. They deliver official papers. And the customer is asking, where's the model? We will model it afterwards. That's not the purpose. You model and make the drawings about the model, not vice versa. That has been the problem in the pilot projects. And now we have seen how to people learn now, make a design really model-based. In modeling perspective, use model all the way. When you have a first 3D polyline, make it as a model. Show, I have a 3D polyline. Do you want to comment this polyline? And make it richer all the way. And also, technology goes fast forward, so they take the advantage from there. That's the pure issue. But maybe the two issues here. It's more important to concentrate to the process than the possible limitations. In Finland, we made a large amount of work to tell the people, if it's a pilot project and everything goes well, it wasn't pilot project. you have to mess something in the pilot project because you do something new. You have to find out something can be done better. And also, do you underestimate yourself or the others? Because we have seen that there are designers who said, I cannot learn this. I'm too old, I'm too young. Normally, I'm too old. I will retire anyway after 16 years. So I will make a drawings. 16 years is a long time to make a very good models. And we have seen the people who are very fans for modeling. Okay, thank you for your time. More information, it's Infrabeam English pages. Also the Building Smart Finland pages. Maybe you have a local pages also. Our pages, Trimble pages. My information if you want to ask something more. Any questions? Yes?
How much more expensive percentage is like designing process? How much percent?
That's a good question. Approximately, that's a good question, how to answer. You should shut down the camera because otherwise I will get caught here. It's 10 to 15% more to the design cost, but some consulting companies have said already that it has been decreased from there because they have used now modeling for a long time. So it comes to the normal level. They are even faster, some consulting companies. But if you see that in Finland it's 3 to 5% from the total cost, the design. So you can save with the modeling to 5 to 14% of the total cost when you have modeled the whole project. So basically the return of investment is much bigger than we thought in modeling. But approximately 10 to 15, but you get money from the construction side. Unfortunately, it's a different phases, and if you are not contractor, you don't get the money back. But the owner gets the money anyways. They will get the better offers with the models, for sure. Okay, thank you.
Yeah. As one of benefits you mentioned flashes.
Yes.
Typically, for example, in Latvia, this topographical survey data is two-dimensional.
Yes.
So designers are remodeling existing underground things.
Good question. In Finland, we have also that most of the data about the cables and the pipelines, it's 2D. And but what we have done in the projects, they think that, okay, it's approximately 1.5 to 2 meters, and they model as a risk area. It's not a pipe, it's a box that in this area we have a pipe. So it's modeled in the model as a risk area or tolerance, and they use it like that. But they have said, for example, construction site, it's very good information that we need, that we know that there is a cable somewhere over here. Then leave it away because it's not true. But in modeling, we have this way that we make it as a risk area with a tolerance. Okay, thank you.